Hello students, welcome to Saurabh's classes. Today we'll be solving the ISI Ms-Qms question paper from the year 2017. Today we'll be solving the question number 23 and 24 from the paper. So let's start with question number 23. In question number 23, it has been said that a function fx is equal to exponential of minus of mod of x plus sine of x plus cos cube x. The function fx is defined by this thing, and we have to check whether the function f of x is differentiable at x equal to 0, whether it is continuous but not differentiable at x equal to 0, whether it is a bounded function which is not continuous at x equal to 0, or it is an unbounded function which is continuous at x equal to 0. So what we have to find over here, we have been given that f of x is equal to e to the power minus of mod x plus sine of x plus cos cube x. So if we take limit f of x as x tends to 0, then gives us limit x tends to 0 e to the power minus of mod x plus sine of x plus cos cube x. So the first term, e to the power minus of mod of 0, will be e to the power minus 0. E to the power minus 0 is equal to 1. This is equal to 1. Sine of 0 is equal to 0, and cos cube 0 will be equal to 1 cube, that will be equal to 1. So it will ultimately come down to 1 plus 0 plus 1, that will be equal to 2. And also f of 0 is equal to e to the power minus 0, that will be 1 plus 0 plus 1, that will be equal to 2. Since limit f of x as x tends to 0 is equal to f of 0 is equal to 2, therefore f of x is continuous at x equal to 2. This is our first part. Now we have to check out whether we have to check out with respect to differentiability. Now for differentiability, what we'll do is that we'll find out limit h tends to 0 f of h minus f of 0 by h minus 0. This will be equal to limit h tends to 0 e to the power minus of mod of h plus sine of h plus cos cube h, and f of 0 is equal to 2 by h. So if we take limit h tends to 0 plus, then this will come down to, as h tends to 0 plus, then mod of h will tend to h, and e to the power minus of mod of h will tend to e to the power minus of h plus sine of h plus cos cube h minus 2 by h. And when we find this out, this upon calculation, this will come down to 2. Similarly, if we find out limit of h tends to 0 minus, then it will come down to e to the power minus of mod of minus h. This will come down to e to the power h sine of h plus cos cube x minus 2 by minus h. This will come down to 0. So the right hand derivative and the left hand derivative are not equal. So f is not differentiable at x equal to 2. This is what we found out at x equal to 0, not x equal to 2, x equal to 0. I have done a mistake over, it is also x equal to 0 over here. So therefore the option B, where it has been said that it is continuous but not differentiable at x equal to 0, is the correct option. Now let's move on to question number 24. In question number 24, it has been said that for -1 less than equal to x less than equal to 1 and x not equal to 0, if we consider the function f of x which is equal to 1 by sin x minus 1 by e to the power x minus 1, then limit of fx as x tends to 0 is either not defined or is equal to 0, 1 or 1 by 2. So we have to find out the limit of fx. Now we have been given that limit fx x tends to 0 is equal to limit x tends to 0 1 by sin of x minus 1 by e to the power x minus 1. This is what we need to find out. This is equal to limit x tends to 0 sin of x into e to the power x minus 1 e to the power x minus 1 minus of sin x. Now we'll use the L'Hospital rule. Since this is of the 0, 0 format, we'll use the L'Hospital rule. On L'Hospital we'll differentiate both the numerator and the denominator by x. So this will come down to limit x tends to 0 e to the power x minus cos of x upon cos of x e to the power x minus 1 plus sin of x into e to the power x. Similarly here also, if you put x equal to 0, then e to the power 0 is 1 minus cos of x is 0, so it is 0 above. And similarly if we put here also, it will be cos of e to the power x minus 1, this is 0, so 0, and sin of 0 is 0, so this is also again 0 by 0 form. So again we will use the L'Hospital rule and differentiate both above and below. Then it will come down to limit x tends to 0 e to the power x plus sin of x upon cos of x into e to the power x minus e to the power x minus 1 into sin of x plus e to the power x sin of x plus e to the power x cos of x. We'll shift over here. This will give rise to limit e to the power x plus sin x, and denominator when we simplify this will come down to 2 cos of x e to the power x plus sin of x into e to the power x. Here if we put x equal to 0, then e to the power x plus sin of x is here it is 1 in the top, and 2 cos x dx, this is equal to 2 plus sin of x is equal to 0, and sin of x and this is equal to 0. So this is basically coming down to 1 by 2, and which is, this is the option D as shown over here. So today we have solved question number 23 and 24 from the ISI Ms-Qms question paper of year 2017. We'll be solving the next questions in the subsequent videos. Till then, keep watching Saraswat Classes videos for more solutions and content. Thank you very much.